3.2 and 3.3. All right. Years ago, I mean, this was a long time ago, we were looking at graphing calculators and when they first started coming out. And one of the things that someone told me is with the advent of that technology, that what happens is it replaces some of the mathematics that we used to do. Okay. It also allows us to do mathematics that we couldn't do before because of its power. Right? And then there's this other section of mathematics that it doesn't really have much effect on. Right? And it's always going to be there. So tonight is a perfect example of where something like Desmos has come along and it replaces a lot of the stuff that is in those sections, particularly 3.2. There's just a lot of things in 3.2 you just don't do anymore because you can graph it in Desmos and it gives you a clear picture of what's going on. So that's what I'm going to start with, all right? And just let you know that you should feel good about using Desmos on some of this stuff, okay? What we're going to do first of all is I'm kind of going to meld these things together, all right? And we're going to start out actually in Desmos, and I just want you to kind of review a little bit about these polynomials, okay? So while you're getting into Desmos, I'm going to kind of do the same thing on my other computer here. But while you're kind of getting there, what I'm going to do is put some things here in the chat. I'm going to have you type in and graph. Okay, and we did this. I don't want to feel like I'm repeating, but I kind of am. So I'm just going to have you put those in. I'm going to stop the share here because there's no reason to have it. And we're kind of investing these things together. So just go ahead and put those in. And we can put them both in because we can turn the other one off, right? Oh, perfect. Right, pretty good for making it up. So I'm just going to look at that third degree first. All right. Now here's what I want you to do. Is I want you to add a d to that, right? So we're just going to go plus d. D is in dogs. And make it a slider. There you go. Okay, so here's what we're going to investigate. And again, we're kind of just taking a step back a little bit, but it's an important, we're going to kind of branch off of this. We want to look at the number of x-intercepts that we can have for this. All right, as I slide D. So go ahead and slide D and look at the number of x-intercepts that you can have here. And then let's do the same thing with that fourth degree. We're gonna we can just add d to it. and then just, it's the same slider, so it doesn't make any difference there. Oh, perfect. Okay, so I think you've probably had enough time to play around with that a little bit. All right, so let's get some ideas here. On the third degree, right? So as I move D around, what are the number of possible x-intercepts I could have for that? 3, okay, good. 1, okay. 1, 2, and 3, all right. So I could have 1, 2, or 3 x-intercepts. All right, cool. Now what about the fourth degree? 2, 3, 4, okay. 1, 2, 3, 4. 0. All right. So we could have 0, we could have 1, 2, 3, or 4 x-intercepts for that fourth degree. All right. Cool. That's what I was hoping. So now here's kind of where we're going with this. Let me get, there we go. So the first thing we want to buy into is that x-intercepts okay, zeros, put this up here, roots, solutions are all pretty much the same thing. Okay. For sure, if I have, and somebody pointed this out last week, if I have an x-intercept, right, say for that cubic that one we had here, let me put this in here, x plus 1, x minus 1, x minus 4, okay, ignoring the d. If I have, I know one x-intercept is -1, and if I put that in, this x, or this x, all three, what am I going to get for y? 0. Very good. So -1 into any one of those x's is going to give me a 0, which is why it's called a 0. Okay. If it's a 0, then it's also called a root or a solution. Okay, so -1 is also a root, a solution, and a 0. Okay, it's the same thing. Same thing with 1 and 4. All right, same thing. Okay, so anything that makes the equation a 0 for y is also considered a root or a solution. Okay, but it doesn't have to be an x-intercept, and I'll show you why a little later tonight, but it's definitely going to be a root or a solution. So if that's the case, then a third degree, okay, a third degree could have one, 2, or 3 solutions, right? And a fourth degree could have 0, 1, 2, 3, 4 solutions. Now, what we're going to say, though, is instead of saying solutions slash x-intercepts, okay, slash x-intercepts. So where we're heading by the end of the night is that we're going to solve polynomial equations higher than a degree of 2. Because when we have one degree, first of all, is just linear. That's just isolating x, put it on one side, put number on the other. You've done that for a long time. Okay. A second degree is a quadratic, which you'd use a quadratic formula for because it solves it for everything, right? The third degree and fourth degrees and so forth, they don't have a formula that we can just type things in and say, hey, can you find me the answer? All right, there's no formula for it. So we need to come up with a strategy to solve those. And that's kind of what we're doing this whole night. All right. But it's going to start out at real basic things and progress on. So that what we're really going to do is look at real solutions, which means I want to say n x-intercepts. Now n would be the degree, where n is the degree. All right, so that's kind of what 3.2 does in a roundabout way. So I'm going to pause for a second here just so you can kind of write some stuff down and digest it a little bit. All right. So the first thing that they talk about in 3.2 is division. Now, is this still sharing it, right? Yeah, okay. So somewhere along the line, all right, you learned polynomial long division. Okay. Oops, what am I doing here? I have no idea what's going on here, guys. Oh, there it goes. Somewhere along the line, you learned about polynomial long division. All right, so if we're going to divide this by, say, x plus 1, right, the way that you know how to do it is by using long division. All right, and you probably are just going, oh, not long division, because most people don't have very fond memories of long division. Okay, and if you did it this way, all right, this was polynomial long division, and the little algorithm that, gee whiz, the little algorithm that I like to refer to as DMSB, all right, and it's divide, multiply, subtract, bring down. Okay, so, and I usually tell my, high school kids, I give them a little thing, it's dead mice smell bad, and it means divide, multiply, subtract, bring down. Okay, so I'm going to run through one of these with you, but we'll never use polynomial division like this again. All right, you probably won't, unless you really like it. So the idea is to figure out, well, what would I multiply this x by right here, because we're going to divide this x by, to get an x cubed. Okay? Can anybody tell me what we would multiply x by to get an x to the third? I'll get about 10 answers here, I bet. What would we multiply x by to get x to the third? You're probably just groaning because it's division. I know. All right, if we'd use x squared, because x squared times x is x to the third. All right, so that's the divide part of this. Now we're going to multiply. So we're going to multiply both of these. Okay, so now I'm going to get plus x squared. All right, because x squared times 1 is that. The second thing you do is subtract. All right, and this is just like long division with numbers. It's no different. The algorithm stays the same. X to the third minus x to the third, gone. Negative 4x squared minus x squared gives me negative 5x squared. Okay, so negative 4 minus x squared. Now the b stands for bring down, so I bring down that x. And now I repeat this. So now I got to say, okay, what would I multiply this x by here, right, to get a negative 5x squared? Anybody got any ideas on that? What would we multiply x by to get a negative 5x squared? Negative 5x. Maybe we just having people a little bit unconfident here. So negative 5x squared. All right, there's the division. Now we're multiplying. Negative 5 times 1 is negative 5x. All right, and now I got to subtract. I'm going to continue to use this algorithm, DMSB. All right, so a negative 5, this negative cancel, so that goes. So then I have x minus a negative 5. Well, that's the same as adding, so that's a 6x. And then I'm going to bring down this 3. And guess what? I got to repeat again. So then I ask myself, oh, okay, what do I multiply x by to get 6x? Let's see if we can get an answer out of that one. What would we multiply x by to get a 6x?
I don't hear something.
I'm hoping that you said 6. I'm not sure what you said there, but I'm hoping that you said 6. So that's going to be 6x plus 6. All right. So we're going to subtract. All right. 6x's go away, and I get a negative 9. And I can't go any further because all I have is a number left. So I can't go any further. So that means that there's a remainder of negative 9. Okay. Now the good news for us is that there's a better way to do that division. Okay, than to go through that long division process. There's a better way. So the better way is to do something called synthetic division. And at first, you might be a little bit concerned about it, but you'll do it I forgot to put the N in there. You'll do it so much that it's going to become really easy for you. All right, synthetic division. By the end of the night, I bet you're really good at it. So let's do the same problem, but we're going to use synthetic division on it. All right, so here I got to get it. Go figure out. So x cubed minus 4x squared plus x minus 3. And we divided it by x plus 1. Okay, so here's how synthetic division works. First of all, you don't focus on so much on the variables. You look only at the coefficients. So that's the numbers in front. So we're really going to look at this, 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 and this. Okay, those are the things I'm going to look at later. Get out of there. Okay, so I'm going to take 1x cubed, so I'm going to put a 1 there. Negative 4x squares. 1x, and then minus 3. All right? I lost my chat stuff. I don't know what happened here. Hope you guys are all still here. Oh, man. Hang on here. Unauthorized. Okay, looks like I'm back. Hey now. What happened here? Yeah, I'm seeing some of the chats on you. You guys are hilarious. Okay. All right. Are we all good now? All right. So now what we're going to do is put this little backwards L thing. Thanks for the fish. It's actually it was my father's fish. He caught it years ago back in Michigan when I lived back there. But that was when I was a kid. So and I just inherited it. So what we're gonna do, yeah. Well, so with synthetic division, you're gonna concentrate on the coefficients here. All right. So you take 1x cubed, negative 4x squared, 1x, and negative 3. And that's as far as I got. All right. So now what we're going to do is divide it by the opposite of this. So since it's a 1, we're going to divide it by a negative 1. All right. And that's what you always do with synthetic division. So you always take the opposite of whatever that is. So now, here's how synthetic division works. First thing you do is you bring down this number. Okay? You always bring that down. Now you take and you multiply this number and this number. So that gives you negative 1. And now we're going to add. So negative 4 and negative 1 give us negative 5. And we're going to repeat that. So now we're going to take negative 1 times negative 5, which is a positive 5. And that's going to go there. And we're going to add. Now we're going to repeat that. Negative 1 times 6 is negative 6, which is negative 9. So remember that what we got up there was also negative 9 for a remainder. So there's our remainder. Our answer would be x squared. Since you divided it, you reduced it down 1 degree. So you start out with a third degree. We divided it and reduced it down to 1 degree. So this would be 1x squared minus 5x, that's 1 less, plus 6. That comes from these things with a remainder of negative 9. All right, so that's how synthetic division works, which is a lot easier than the long division. Okay. All right, so let's try another one with synthetic division, right? Okay, so let's say we have x cubed minus 2x squared plus 4x minus 8. And let's say that we want to divide that by x plus 2. So what we're going to do then is go across here with our coefficients, right? So it's going to be 1x cubed. So it'd be 1, negative 2, 4, and negative 8. And we're going to divide it by the opposite of that. So you don't worry about the variables so much. You just worry about those coefficients. And again, this is just a symbol for synthetic division. Why negative 2, not 1? Because you're looking at this. Okay, so it's going to be the opposite. Okay, good. All right. So remember, the first step in synthetic division is just to drop that 1 down. So whatever that is, you're just going to drop it down. And now we just multiply. So negative 2 times 1 is negative 2. That's going to be negative 4 when we add. Negative 2 times negative 4 is 8. That's going to be 12 when we add. Negative 2 times negative 12 is negative 24. And that's going to be negative 32 when we add. So negative 32 is the remainders. Now what we're going to find out later on here is that the remainders are actually going to tell us something. Okay, so they're going to be kind of important. So remember, we started with a third degree, so it's going to be 1x squared minus 4x plus 12. That's these numbers right here. And the remainder, like I said, is just going to be 32. So I'm just going to write that over here. All right.
Can you explain again how you did the thing really? Like, you did the negative 2, like you dropped the 1 down, I get that, and then you did 2 times negative 1. Or negative 2 times 1? Or is that?
Yep. Yeah, you just multiply.
But which numbers are you multiplying?
Okay, so then here's what, so we're dropping down this 1, right? So now we're taking negative 2, multiplying it by 1, and that gives us negative 2 right here. Okay? Then I added them. So now I'm going to take this negative 4, multiply by negative 2, and I get 8. Right? So then I add that up. So now I have this thing. So I take 12 times. See, I'm always going to this thing right here. And that gives me negative 24, and I add. Now I'm done because I got nothing else. Okay. So let's do one more, and then, yeah, we'll take a break for sure. So let's do one more. So let's do something different. So let's do a 2x cubed here, minus 4x squared, plus 5x, minus 10. and we'll divide it by x minus 1 this time. Okay. So what's going to be the coefficients that we're going to have in a row here? What are those numbers going to look like? Yeah, 2, -4, 5, -10. Very good. All right, you got it. Now, what are we going to put down in this backwards? What's going to go in that backwards? 1. There we go. Again, right, because it's going to be the opposite of that. Yep, +1. Good. Now you're just going to do synthetic division. All right, so see if you can do it along with me here. All right, so we're going to drop that 2 down. See, we're multiplying here, adding, multiplying, adding, multiplying. There's a remainder. So then 2x squared minus 2x plus 3, remainder -7. All right. So that's synthetic division, and that's what we're going to use a lot of tonight. Okay. So yeah, good time. Let's go ahead and take. We'll come back at about 6:42. And what do we do about the remainders? Just leave them. Yeah, they're going to be important to us when we come back. We'll start talking about the remainders and what they do. Okay. So let's come back at about 6:42, and we'll do some more. We're kind of back here. So here's what we're going to do. All right, I'm going to put this into the chat again here too. And I'm going to have you go to Desmos and graph this. I want to change it like this. There. So I basically have you graph that in Desmos and tell me one x-intercept. One ax-intercept. I don't know what that a is doing there. It's supposed to be an x. One a-intercept. It's 1x. Four. Okay? All right, here's what we're going to do. Take that x-intercept now. All right? And I'm trying to get this thing to react. There we go. So we're going to take this x cubed minus 5x squared plus 2x plus 8. All right? And we're going to divide this by x minus 4. So I want you to do synthetic division on that and tell me what you get for a remainder. Okay? Do synthetic division. Tell me what you get for a remainder. I got one answer. Let's see if we can get somebody else that did the same thing and gets the same thing. Let's see if we get somebody else that do synthetic division. Okay, got negative 24. That's why we like to have you do it, because, you know, we got 32. Looking for the remainder here. So I got 3 different answers. Let's see if we get any of the other ones that the people said here. Again, we're going to do synthetic division on that, and I want the remainder. Okay, that's okay if you're confuzzled or confused or whatever. That's why we're doing this. Okay, like I said, by the end of the night, you'll be experts at it. I got 4 different answers. Is anybody getting? See if anybody can come up with something that might be the same, or I was wrong. I got 0. Oh, now we got someone got 0. Okay. Negative 16. Yeah, I got 0. Okay. So we got a couple people that got 0. So let's walk through it. Right. So again, we're only interested in the coefficients, right? So 1, negative 5, 2, and 8. All right. Those are my coefficients. Negative 5, 2, and 8. I'm going to divide it by, remember, always divide by the opposite of that. So it's going to be 4, right? So it's not x minus 4. It's going to be 4. Now we're going to bring this down and multiply. Negative 1 and multiply. What's going on? Let's see. Did I do something wrong? Did I write this? Oh, let me see here. Is it negative 4? Oh, yeah, thanks. Thank you. That was getting concerned. I'm going, what the heck? There we go. See, it's easy to make a little mistake, though, for sure. So we got 0. All right? So our remainder there is 0. Okay? Now, let's do this again. But we're going to do a different one this time. Okay? So I'm going to put another one in here. Here we go. Y equals, this one's going to be 4x to the third minus 16x squared. Alright, same thing. Find an x-intercept. Now, when you find the x-intercept, tell me what it is, because I'm looking for one particular x-intercept that we're going to use. That's the one, Ashley. Nice job. Yep, Sammy, that's the one we want right there. Okay, so here we go. We're going to take 4x cubed minus 16x squared minus 13x plus 70. All right, and we're going to divide that by x plus 2. Okay, go do your synthetic division on it. Let me know what you get for a remainder. Okay, I got 3 zeros. So you're right. that's what we should get. All right, so if we do this, 4, negative 16, negative 13, see how much better you're getting at it now? Negative 2. All right, bring down that 4, negative 8, negative 24. Let's see, it's going to be 48. All right, and I'm going to add those. So 35, negative 70, 0. All right. Okay. Now, let's talk about this a little bit. All right, so we divided by negative 2 here. All right, and we divided by 4 here. What did those numbers represent in those polynomials? They were the zeros, right? Zeros, what else are they? Accents, yep, good. Okay. And a remainder was what? 0. Okay. So there's something in this 3.2 that's called the remainder theorem. And here's what it basically says. Now there's two parts to it. Okay. So when using synthetic division, first of all, and you divide a polynomial by, let's say, C, okay, where C is a number, all right? If the remainder, I'm going to put a bullet here, if the remainder is 0, then C is a solution. Now remember, if it's a solution, it automatically makes it a root and it's an x-intercept. Okay? I mean, it could be an x-intercept, I should say. So now you know about the remainders. So hey, if I get a remainder of 0, that tells me something about that particular number that I divided by. All right? Okay, so I'm going to do this here real quick. I'm typing something in the Desmos. And this time, I'm not as interested in you guys type it in. Cubed. And I'm going to share the screen with you. Okay, so I'm going to stop this share. And start this share. All right, so I have this pretty funky looking graph here. All right, so what we're going to do is I'm going to ask you to do some synthetic division. Now, we haven't done one on a 4th degree, but it doesn't make any difference. All right, you're still going to focus on these coefficients. Negative 4, 12. Here, let me put this in. So there you go. Negative 4, 12, 29, 57, negative 57, and negative 70. Okay, so negative 4, 12, 29, negative 57, and negative 70. All right. So what I want to have you do is I'm going to have you do synthetic division, and I want you to do it on, let's go with, I just want to make sure we don't pick one of these. Okay, do it on 3. Okay, so let's do it on 3. Okay, so I want to put that in here. Do synthetic division. Go. Tell me what the remainder is. It would be, yes, Ash, that is correct. But you're just going to go ahead and in that inverted L there, you're just going to put a 3. Again, just tell me what the remainder is. Put it in the chat. Okay, we got 2 different answers. We got a 20 and a 100. That's why we need make sure we get other people shooting them at us so we know what we got here. Okay, we got another 20. Let's get one more here. Okay, we got a 20. All right. So I'm going back to this share here, and here's what I'm going to type in: f of 3. Oh, look what f of 3 is. What does it say? What is f of 3? Right there. 20. Okay? It's 20. All right? Let's do synthetic division again. All right? This time, let's do it with negative 3. Okay? So, synthetic again. Try it again, this time with negative 3. Let's see what the remainder is.
I'm a little confused because, like, I got all the way to the negative 4, 12, 29, but when I did it, the next one, negative 57, shouldn't it be negative 57 minus 87, which is not 30? Or am I missing something there?
Let's take a look at it here. Four, 12, 29, negative 57, 70. And we went by to 3. Okay, so negative 4. 3 times negative 4 is negative 12, which gives me a 0. All right? So now that's going to be 0 there, and I get 29. So far, so good?
Yeah.
Now I need 29 times 3. Oh my goodness. So let's see, 27, so that 87?
Right.
Okay, so then I should get...
But negative 57 minus 87.
Should give us 30, right? So what happens?
If you added them, it would.
Yeah.
But I thought we were subtracting.
Oh, okay, yeah, we are. Oh, so we're adding them. So that's going to give us 30, right? And now 3 times 30 is 90, which gives me 20.
But why are we adding it there? Because negative 57 minus 87 is not 30.
But you're not minusing, you're always adding. See, because think about it. We added here, right? 12 minus 12 is 0. And the only reason why it was minus is because 3 times negative 4 is negative 12. So that tells us what operation to do.
So
We're always adding on those.
Maybe that's why I was having trouble, because I thought we were subtracting.
Well, you're only going to subtract when we have a negative 12, like we had a negative 12 there, right? So, I mean, you can think of it as either adding 12 plus a negative 12 or 12 minus 12, but yeah, no, you're adding them. Okay, so I'm getting some people giving me some answers here. I'm getting two negative 286s, some 700s, some 170s. Let's see if we can get one more. We got a 600 something somewhere. All right, so let's find out what it is. So I'm going to put negative 3 in here this time. All right, and it's negative 286. Okay, so if I have, remember going back to that remainder theorem, says that, hey, if you get a 0, right, then the number you divided by is a solution or x-intercept or root. Here, what it does is it tells you what the function is at that value. Okay, that's what it's telling me. So if I come in here and I just put like an R in there for root, right, and I slide this, then it's going to tell me what it is at that value. Okay, the remainder is just going to be what it is. See, here I got negative 8638 when it's 7. So you can tell I'm not even going to, I mean, this thing just dives way down there, right? So let's go to, maybe I can come up here and trace on this and get to negative 1.1, right? And look, it's coming down, and it should be about 5.9. There it is, 5.962, pretty close. Okay, so whatever this number is in here is telling you what that is at that particular what the function is at that particular value. So that's what the remainder theorem tells you. Oops. Here, let me lasso this junk and get it out of the way. There we go. So it also says that the remainder is the value of the function at C. Okay. So when I can't remember, sorry, who it was that asked me about the remainder. Now you know. So if the remainder is 0, you know it's a solution. If the remainder is 10, then you know what it is if you take f of whatever you divided it by. Okay? So that's the remainder theorem. And that is in your section 3.2. Now, again, remember I was telling you that some of the stuff that's in here is being replaced by decimals. They also have a thing called a factor theorem, which is basically the same thing. It just says that if it's 0, then it's a factor, right? If it's not 0, then it's not. Now, what does that mean? Well, that just means that you can break it down into its factors. So I'm going to get rid of this here. There we go. So if we did synthetic division, all right, let's say we did synthetic division and we got a 0, and we did synthetic division with 2. Now see how I'm putting that as x minus 2? All right, that just means that that particular polynomial function has an x minus 2 in it when it's written in factored form. All right, so if the remainder is 0, then you know that that's going to be an x minus 2 if it's at 2. If we divide it by a negative 2, then it would be the opposite, and you would put that there. Okay? All right? So really the factor theorem and the remainder theorem are the same thing. Okay? Now they have a thing in here called Descartes' rule of signs, which is one of the things that's been eliminated. So we don't even talk about it. They also have a thing called the rational zeros theorem, which is really tedious, and again, we don't talk about it, so it's been replaced. All right. So here's kind of things though that they're going to ask you. All right. They're going to say, let's say that you have 2x to the third plus 11x squared minus 7x minus 6 equals 0. And what they want you to do is find the, move this over here, real zeros. Okay? Find the real zeros. Now, what do I mean by decimals replaces stuff? Well, remember what we said in the beginning. Zeros and x-intercepts are the same, right? How can we find the x-intercepts of this? What would we do? Yeah, you're going to graph it. Yeah, put it in decimals and graph it, right? Because it's going to tell you what the x-intercepts are. Okay, so go ahead and do it. Type it in, graph it, and see if we can figure out what the x-intercepts are, right? Hopefully they're nice, but maybe they're not. Oh, good, they are. -6, -0.5, and 1. So what does that mean? That means I can rewrite it, okay, in this form. So this would be x plus 6, it's the opposite, x plus 0.5, x minus 1, okay, and I'm going to toss a 2 out in front. Where did that 2 come from? Right here, okay, right there. So that's written in factored form now. Okay, so this is factored form. Now, what would happen if we did synthetic division with 1? What are we going to get for a remainder? So we're going to do, let's say we did it. We're not going to, but let's say we do synthetic division on that with 1. What are we going to get for a remainder? Yep, 0. You're right. Because it's an x-intercept, right? Remember, the remainder theorem says, hey, if you do synthetic division on a value, say C, and your remainder is 0, it's an x-intercept or a solution. Vice versa, if I take an x-intercept or a solution and I do synthetic division on it, I doggone better get 0. If I didn't, then I made a mistake. All right, that's what the remainder theorem says. Okay, and I could get the same thing if I did negative 6 or if I did negative 0.5. I'm going to get 0. Okay, that's what the remainder theorem says. Okay, there are some other things in here about bounds. Okay, upper bounds and lower bounds. Basically, again, you can use Desmos to figure out if it has a lower or upper bound. All right. If we have a, oops, I got a little bump in there. If I have a fourth degree that looks like this, all right, we say that this is bounded because there's no value higher than that. Okay, whatever this maximum point is, it's an absolute maximum, then that function is bounded. Okay, it doesn't have a value higher than that. A third degree, though, is unbounded because it's going to continue to increase. All right, so they're going to talk about upper and lower bounds. I don't really ask you any questions on that, but it's in the book, and I just wanted to make sure that you knew it. And you can figure it out using the synthetic division, but it's really not. Again, Desmos replaces that math. Okay. One other thing in 3.2 that's kind of important, I guess, is this thing called the intermediate value theorem. All right, so let's talk about it. Let's play with it first. So here we go. I'm going to give you this function. I'm going to do the synthetic division on this for you because we haven't done anything like this. Let's find f of 1 and f of 2. Okay, so what we're going to do is we're going to find those values, right? Now, I could just plug them in, okay? Or I can use synthetic division. All right, so you could do this either way, right? I could just put 1 in there, which would really not take very long. But I want to show you how you do synthetic division on one like this. So I'm going to pick the 1 first, all right? So I'm going to go 1, Now here I'm going to go 1x to the 5th. Now do I have any x to the 4th in there? No. So that means I'm going to put a 0 as a placeholder. Okay, I don't have any x to the 4th, so I'm going to put 0 there. Minus 1x cubed. I don't have any x squares, so that's a 0. I don't have any x's, that's a 0. So now I just have a -1. See, so every time that you don't have that particular power, you have to put a 0 in there as a placeholder. Right? You have to do that. Now we can do synthetic division. Okay, so we get 1. 1 times 1 is 1. So we're adding. 1 times 1 is 1. There's a 0. 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 And we shouldn't be getting 0 here. Yeah, we shouldn't. Oh, this is an... Oh, let's see. So 1. See, it's easier to make mistakes. 1, 1, 0. 1 times 0 is 0. 1 times 0 is 0. Why am I getting... Oh, that's 0. That's right. But so that gives me -1. So my remainder is -1. Okay? Now we're going to do the same thing on 2. Okay. 1, 0, -1, 0, 0, -1. All right. 1. That's going to give me 2. That's 2. That's going to give me 4. That's going to give me 3 because I'm adding these. It's going to give me 6. That's going to give me 6. That's going to give me 12, 12, 24, 23. Okay? So, off to the side here. Here's what this says. Here's my graph. I have no idea. I really don't know what this looks like. Kinda. It is a 5th degree. Right? So, basically what this is telling me is that at 1, I got a -1 right there. But at 2, I got a positive 23 way up there. Okay. So that means that somewhere between 1 and 2, there is a root or a solution or an x-intercept. And that's what the intermediate value theorem says. It says that when you go from a negative to a positive or a positive to a negative, then you know it's got to cross the x-axis, which means that there's a root there. But again, you could graph it and do the same thing, right? I mean, you could just put it in there and go Desmos and click and go, oh, yeah, there's a root right there. I can see it. All right. So is it important? Not a whole lot because Desmos kind of replaces it. Okay. Any questions on synthetic division or remainders? Don't hesitate to ask. I want to share this screen. Okay, so this is in the textbook here. All right, so I'm going to look at the problems here. We're doing 11 through 16. It says use the remainder theorem, hopefully you guys can see this, to find the remainder when f of x is divided by x minus c. Then use the factor determinant to determine if it's a factor. So what we're going to do, where is my annotations? Here we go. So I'm going to take this here, right? And I'm going to divide it by... Now, I'm not going to divide it by x minus. I'm not going to divide it by a -2. Remember, I'm always choosing the opposite. So then I would take 4 and -3 and -8, right? And 4, and I'm going to do synthetic division with +2. It's going to be the opposite, right? and then I work through here. So 4, 8, 5, 10, 2 times 2 is 4, and I get 8. All right. So here it is. I get 8 for my remainder. All right. So it's asking you to use the remainder, find the remainder when f of x is did. I did. Then use the factor theorem to determine if it's a factor. If it's a factor, that means it's an x-intercept. All right. So is 2 an x-intercept of this particular one? Assuming that I did everything correct here. No. That's right. It has to be 0 there. My remainder has to be 0 in order for that to happen. That's how you do those. Okay? You're just going to divide it out using synthetic division. Check it out. Can you use Desmos and graph it? Yeah, you could, but it's a good idea that you do synthetic division and practice it a little bit. All right? That's how you do those. Straightforward. After we do 11 through 16, we jump all the way to 45. All right, so I'm going to come down here, go to 45. Let's see what it says. Use the rational zeros theorem to find all the real zeros. We skip that. We don't even care about the rational zeros theorem. It's outdated. We're going to find all the real zeros. How would we find the real zeros of this? What would we do? Yep, you're going to graph it. Yeah, you're going to graph it, right? So right now, in Desmos, okay, graph number 45. All right, and then tell me what the x-intercepts are. So graph it and find the x-intercepts, because that's what we're doing, finding the real zeros. Hopefully they're nice. Okay, good, they are. So then I'm going to go like this, right? X, because it says use the zeros to factor. So we're going to write it in factored form. So it's -3, so I'm going to go with a +3 there. Okay, always doing the opposite. X plus 1, like that. And x minus 2. Good. Done. That's all I do. So see, on all these, you're just going to graph them. Okay, find the x-intercepts, write it in that form with the parentheses. All right.
And if they have a coefficient in front, like a 3 or 2, we would write that in front of all the factored form there?
Yeah, you would. You would.
Okay.
Yep. Let's see what else we got here. 57 through 64. Solve them. Again, going to graph them. Okay? Type them in, graph them, put down the x-intercepts. You don't have to just write down it. Again, you're just graphing. 69 through 72. Find the bounds. Okay, let's do one of these. So let's graph this. All right. And why did I give you some of these ones? I thought I pretty much stayed away from them. Well, we'll graph it anyway. So go ahead and graph it. Here, I'll just do it for you. Let me graph it. And then we can share it and take a look at it. Let me clear this off. There we go. I don't think you can see this, but we'll get you to see it soon here. Oh, I can see it. Good. All right. So now I'm going to type that in. Let's see. What was it? X to the fourth minus 3x squared minus 4. X to the fourth. minus 3x squared minus 4. I'll put a y equals in front because I like to. There we go. All right. So this is bounded here and here. But there are not going to be any more zeros between -2 and 2. All right? So then what they're probably going to say for the bounds, all right, is that it's between -2 and 2, that there are no other zeros past these numbers. Okay? So there's none past -2 and there's none past 2. How do I know that? Well, because I can graph it in Desmos, I know this is increasing on both sides as the end behavior is. I know it's not going to come back down. All right, it's a fourth degree. It makes a W. So then -2 to 2, it's bounded in between there. It's also bounded down here, but they're more interested in these two numbers. All right. If it was to come down and around, right? So let's say this is x to the 5th. Let's say I can do that. All right, then I would say that it doesn't have a bound. I mean, let's see. So here, 1.648 is the only number, the only one that there is. Okay, but this is ever so decreasing. So there isn't, it's not going to loop back up. All right, it's not going to. Because again, if it did, it would have to be an even power. All right, and this is a 5th degree, so it's going to have this little N shape to it. So that's why we drilled all that. I remember I kept saying, you got to kind of know that. Okay, what is this degree telling us about the graph of this? Okay. All right, so 1.6 is the only root. So, I mean, I guess it's bounded at 1.648, whatever the heck that is. Okay. Yeah, so the answer would be -2 to 2 for that other one. Yeah, I'm not exactly sure what they're going to rephrase that as, but you can just put -2 to 2. Is our -2 and 2 are our bounds. Let's see, what was, let's see what else we got. What else did I have you do? 7981. And it says here it shows, so again, here you're going to use that intermediate value theorem to show that each polynomial has a 0 between here. And again, you can just graph this, right? You could graph it and show it, all right, that if it has one between there or not, okay? Or you can use synthetic division on 0 and then on 1 and see if they're going from a positive to a negative or a negative to a positive. Okay, I really don't care which way you do it. All right, you can either graph it or you can use synthetic division. But that's all you do on that. Okay. So that is, sorry. So that is those ones. All right. All right. Hang on here. What's going on, Abs? What are you doing? Come on. What's the matter? Nothing in there, Abs. You're okay. We'll see Mom. Okay. Hey. Shh. All right. So it should be open in detail because I made them all visible. I can double check and see. Hey. No. Come on. Let's close the door. There you go. I'll double check that. Oh, okay. So let's do. We're almost done here. It doesn't seem like they are, but we really are. We're gonna go ahead and do some solving. All right. So I'm gonna go back to sharing here. So we're actually going to do some solving of polynomials. Okay. So again, I have some written here that I'm going to put down in the chat and have you graph them, right? And find some x-intercepts. And then we're going to go from there. So let me put this in here. Now I'm going to put an equals 0 on there. Well, let's just do that. So we're going to put that in. Okay, so go ahead and find the x-intercepts. All right, graph it, find x-intercepts. Okay, good, good. Okay, so we got a couple people gave us some x-intercepts. That's good. What was really good is that you rounded them. All right, because we want to find exact values. All right, exact values. Yep, good. One of them is an exact value, right? -2 is a good number. So here's what we're going to do. We're going to take and we're going to do synthetic division. All right, with -2. So this time I'm not taking the opposite. Because it's an x-intercept, I'm going to just divide by that. That becomes a little confusing for people. They go, what do you mean we're not? But before we always were. When I said divide it by x plus 2, when it was written in that form, then we did the opposite. But if we're just taking strictly the x-intercept, we don't. All right, we're just going to go right with whatever that number is. Okay, go ahead and do synthetic division. All right. And then I want, this time I know what the remainder is, and you should too. I want to know what you get here. Okay. Okay, so you're telling me I get 1, -3, and -7. Cool. So that means that this is going to be x squared minus 3x minus 7. All right. So if I write this, I can write it in this form. Okay, so what I've done is taking this polynomial here, okay, and reduced it down to here. So if I FOILed these things, I should end up with the same thing that I started with, all right, because this is in factored form. Now, if I set this equal to 0, I know that one of my answers is -2, but I already know that because I graphed it, right? So I need to look at this part. The good news is that it's a quadratic, which means to solve that, I can use the quadratic formula on it, right? So remember the quadratic formula goes like this. All right, so I'm going to plug in the numbers. So first I'm going to write this. A is 1, B is negative 3, C is negative 7. So look, those are the numbers you gave me. All right, 1, negative 3, and 7. So now I'm going to put these in. So I'm going to get a 7. Oops, excuse me. I'm going to get a 3. So I'm going to get a 3 plus or minus square root. I'm going to square that 3 minus 4 times 1 times negative 7 all over 2. All right, so now I'm going to get 3 plus or minus square root. What do I got? I got 4 times 1 times 7, which is 28. 9 and 28 give me 37 over 2. Those are my other solutions. All right, so if you did that in Desmos, if you took 3 plus the square root of 37 divided by 2, you should get, what was it, like 4.5? If you took 3 minus the square root of 37 divided by 2, you'd get the other one, whatever that one was. All right, so that's how you solve these. Okay, you're going to use synthetic division, but first you got to graph it because you got to find a nice x-intercept that you can work with. All right, let's try another one. Okay, so let's try this one. So we're going to go x cubed minus x squared. Now I'm putting this in the chat here. Minus 9x plus 14. Gee whiz. Okay, now I'm going to put a 0 there. We're going to solve this, right? Okay, so graph it. Tell me what an x-intercepts are. At least the nice ones. I can't do anything about the other ones. Okay, so negative 2 or 2? Which one is 2? Okay, that's all right. So let's do synthetic division. Okay, see how I told you were going to be very good at synthetic division by the time the time's over. What are we going to put in that inverted out? What are we going to divide by?
Just 2.
Just 2, right? Whatever the x-intercept is. Okay, sweet. All right, here we go. 1, 2, 1, 2, negative 7, 14, and I know I'm going to get 0. If I don't get 0, I made a mistake. Okay, so automatically I know what I'm going to get. So here's what I'm interested in. All right, I know that's a quadratic. Okay, because I reduced it down. I'm going to use quadratic formula on that. I'm not even going to mess around with it. I already know that it's something that Desmos is rounding. So I'm just going to put this in. All right, so negative 1 plus or minus square root of 1 minus 4 times 1 times negative 7 all over 2. And I keep going. 4 times 1. Oh, it's just going to give me 28. So it's going to give me 29. And divide that by 2. And there's my other 2 roots. Okay. There it is. That's how it works. Pretty slick, right? Okay, we're going to keep progressing on this. All right, I'm going to give you another one. This time, I'm going to give you a 4th degree. Oops, I got to put a negative in front of it. Okay, so there's the next one. Type that in. Give me some x-intercepts. All right. -1 and 2. Okay, good. Now, it might have some other ones, right? But maybe they're decimals. We can't understand. They're not exact values. All right, so now we have 2 of these. So we're going to do synthetic division again. All right, and you can do it right along with me. Okay, so we're going to divide this by. Now, which one do you want to divide it by? -1 or 2? It doesn't matter to me. You pick.
-1.
All right. Okay, here we go. -1, 1, 3, adding, right? -3, 5, -5, -14, 14. I know I got to get 0 there. Okay, I know I got to get a 0 there. So now we've reduced it down, but what have we reduced it down to? What degree is it now? It's a 3rd degree, right? Yeah. Okay. I don't have a formula for a 3rd degree. Okay. I don't have one. So what do I got to do now to get down to a 2nd degree? What should I do?
Do we divide it again?
Exactly. And what are we going to divide it by?
-1 again?
You can't. You already used it. What's the other x-intercept?
So 2.
That's right. See, we're going to divide it again by 2. And we know that we're going to get 0 there, because if we don't, we're going to make it, it's all messed up. Okay? Look at that. And now you're down to a quadratic, and you can use a quadratic formula. Okay? So 3rd and 4th degrees are the highest ones you're going to have to solve. You don't have to worry about, at least on this part, right? But that's how you would do that. Okay, and you can. I'm not going to run through the quadratic formula because I think you can probably whip through that pretty easily, right? You're just going to do it with these guys. Okay. All right. Now, let's go back a little bit to what we did in the very beginning of tonight. And we said if we have a 3rd degree, we either have 1, 2, or 3 solutions. If we had a 4th degree, we'd have 0, 1, 2, 3, or 4 solutions. All right, guaranteed. Well, that's actually called the fundamental I'm just going to clean this up here. Theorem of algebra. Okay? And what it says is that a polynomial of degree n will have n solutions. Okay? So I'll let you write that down. Fundamental theorem of algebra says a polynomial of degree n will have n solutions. So far, everything that we've done, right, works with that, because when we had a degree of 3, we had 3 solutions. We had a degree of 4, we had 4 solutions. We found them all. All right. In this case, here's what this says. So if I have a cubic, right, there's my 3 solutions. There's my third degree, right? But remember, you told me in the beginning that I could have this situation where I only have one x-intercept, all right? But we have 2 solutions, okay? Or excuse me, we have 3 solutions. We know that we're going to have 3. So let's take a look at this. So here's one I want you to look at. So x to the third, I'm going to put it in the chat again. All right, plus 2x squared plus x minus 18 equals 0. All right, so I put that there. Okay, now graph that and tell me what the x-intercepts are. Two. All right. Does it only have one x-intercept? Yes. All right. Let's do some Let's do some synthetic division on this. Okay. So let's see. X cubed. It'll start writing sooner or later. It always does. Maybe. Well, I don't want to waste time. You guys do some synthetic division on it, and let me know what the. I know the remainder is 0. Give me the other stuff. Okay. Let's do the quadratic formula on that. Okay, so we're going to do the quadratic formula on 1, 4, and 9, right? So here we go. So negative 4 plus or minus square root 16 minus 4 times 1 times 9 all over 2. Negative 4 plus or minus 4 times 1 is 4 times 9 is 36. But 16 minus 36 is negative 20. Okay? So you're probably going, oh, wait a second. That's why it only had one x-intercept. That was real. Because the other two are imaginary. Right? So here's my I coming out of there. And that's what's happening there. Okay? The fundamental theorem of algebra says it's going to have 3 solutions. You might only see one x-intercept. That means the other 2 have to be imaginary. And if there's one imaginary, there automatically has to be another one because of this thing right here, that plus or minus. Okay? So if one's imaginary, that means that another one's imaginary. Now on this, in your book, what they're going to do is they're going to break this thing down. Okay, so they're going to say 20 is 4 times 5 Square root of 4 is 2. They're going to put that right that. They're going to rewrite it. I term's going to go there. 2 goes into both of those. And they're going to leave it, and they're going to say, hey, there's your answer. Okay. That's all fine and dandy. I'm okay with that. All right, because this is not about breaking down square roots. It's about solving polynomials. So I root 20 isn't any different than negative 2 plus I root 5. All right, there isn't any difference there. It's the same doggone thing. Right? So I'm not really too concerned that you break it down. Right? But the back of the book's going to do that. Or the answers in the book are going to do that. Okay? So this is kind of an important thing on the fundamental theorem. So if you have 1 x-intercept and you do synthetic division, on a third degree, then you know your other two are got to be imaginary. Okay. Here's one last one here. Well, actually, let's do this one. All right. So this is going to be x to the 4th. Okay. Plus 5x to the 3rd. And I'm going to let you play with this one. Plus 10x squared minus 12x minus 72 equals 0. Okay. Go solve that. All right. Remember, you got to graph it first. Okay. Go solve it. If you have questions, ask me. Um,
So I didn't graph it. I just kind of did the division, the -3, then I went to the 2.
Oh, so when you did -3, so what is the
Yeah,
one?
because
What does the 1, 4, and 12 represent?
that's the second set of division. So I broke it all the way down to where it would be x squared plus 4x plus 12.
Okay. Now you got to do the quadratic formula on that, right?
Yeah. You want me to keep going? Okay.
Oh yeah. Solve it out. Okay, good. Looks like some people are getting some answers. That's awesome. All right. So here's what I started out with. Okay. Yeah. Did my synthetic division. All right. It's a fourth degree. I know I'm going to have 4 solutions. Fundamental theorem tells me that. Let's see, I got a -3 as a possible x, or as an x-intercept. I know I'm going to get 0 there. 1, -3, 2, -6, 4, and -12, which is 24. There it is. All right. Now I'm going to take this one, do synthetic division again, this time with my other x-intercept, which is 2. And it doesn't matter which order you go in. All it does is just change these values. It doesn't make any difference. You're going to get the same spot. All right. There's that 1, 4, and 12. So now I use a quadratic formula. Let's see, this is going to be a -48, which is a -32 over 2. Always make sure, though, that you bring that I out. Okay, I'm not too concerned about you breaking down to 32, but bring the I out. Okay. So, I mean, that's it. Now, a couple other quick things here. If we have a cubic and it does this, right, we know that this is a double root. Okay, so that means it's a multiplicity of 2. So if this is, say, -4 and this is 1, right, I can write this as x plus 4 times x minus 1 squared, because it's a multiplicity of 2. It still has solutions of -4 and 1. All right, it's just I only got 2 of them, but that's okay, because you guys told me in the beginning, hey, I could have 1, 2, or 3 x-intercepts. All right, so that's okay. All right. You might run into something like that. If you run into something like that where you have a, and by the way, you can pick -4, well, you wouldn't need to in that case, but if you have a 4th degree, okay, I don't really need, here, let me erase this part. Where it looks like that, okay, and let's say that this is 3, okay, then you would take that and do synthetic division with 3 twice, because it's a double root, okay, it's a double root, all right, so, but it doesn't change anything, you're still doing the same thing, okay. They're going to ask you, let me show you on here, I'm going to stop this share. I just want to make sure you can do these. Start this share. And go to this. Okay. Here it says the information is given about a polynomial f of x whose coefficients are real numbers. Find the remaining zeros of f. Let's take a look at number 7, for example, here. Okay, right here. It says the degree is 3. One of the zeros is 3, and the other is 4 minus I. All right, I'm going to come over here. I'll just put it down here to write it. So I'm going to write it in factored form. So I know that x, right, minus 3, okay, because the x-intercept is 3, so there's that opposite idea, all right, parentheses. Now I know that 4 minus I, how do I do that? Well, I'm going to write it like this, minus parentheses 4 minus I, okay, and I'm going to put that in like that, and I'm going to leave it, all right. Now remember, if one of these is a solution, 4 minus I, automatically that means 4 plus I is the other solution, and those are called conjugates. Okay, conjugates. by the way, that problem's done. You don't have to foil it. Please don't foil these, okay? It's a mess. Yeah, so you're done. If 4 minus I is a solution, then that automatically means 4 plus I. If you have one imaginary, you got to have another. You can't have odd numbers of imaginary solutions. It's impossible. So you're always going to have even numbers of them. All right, and you can see all these are going to be like that. Okay, and you're just going to write them in this form. This is always going to be the minus. The sign that changes is this one. Okay, the one is right there. See how I changed that one? That's the one that's going to change. These ones will stay the same. Okay. So over here. Same thing's happening here. Same thing's happening here. It just says that the multiplicity of this particular one is 2. So that would be like that x minus 4 squared. Okay, but again, I have a 3 plus 2i, so that automatically means that 3 minus 2i is another solution. Okay. 23 is a good problem because it says if 2i is 1, 0, find the other 2, because you know it has a degree of 3, so you know it's going to have 3 solutions, right? Well, if 2i is a solution, that also means that negative 2i has to be another solution. Okay. Now, how would we find a third one? How would we find a third one? What would we do with this? Yep, graph it. Right? You're just going to graph it. Okay. And it should tell you. Right? That's it. That's how those work. Okay. And then these ones is what we've been doing. All right. So I think you're going to be, you just got to, again, synthetic division, a lot of synthetic division. Okay. And work through them and see how they go. We'll see where we are on Wednesday. Okay. So we've definitely gone long enough today. Thanks for hanging in there. And if you have any questions, ask me. If you have any questions at all. Yeah, I know. It's a lot, right? Okay. Again, thanks for hanging in there. I'll be putting those grades up a little later. And I'll see you guys on Wednesday. Hang in there. We're almost done.